Today is the last day in the notes packet, so we're going to review everything and put all of our transformations together. So our very first one says ABE. So we're looking at this triangle right here, and we're mapping that to EFH. There's EF to H right there. We'll notice it's aimed in the same direction. It's still upright. It just slid down and over. That's what we call a translation. My next one, BCF. So B to C to F. We're looking at this triangle right here. I'm mapping that to IHF. IHF is right here. I'll put a little dot there. So we'll notice it didn't flip down. There's no way to do reflection in these triangles. What it did is it spun around 180 degrees. So this is a rotation. If you'd like to add on 180 degrees to remind yourself, I think that's a good idea. Okay. But just remember, there is no way to get a reflection. If I was to flip this over, this triangle would be right here. Okay. So it's either translation, I slide it down and over, or it's a rotation. It is possible to do a combination. So for example, HIJ, HI to J is this triangle right here. F to E to B, F to E to B is right here. We'll notice it rotated it. I don't quite have one right there, but it rotated around and it slid it over. So it is possible to do more than one. For this one, I would say rotation and translation. Okay. I also went ahead and added one. So HIJ. Go ahead and you can write this one on the bottom of your notes. HIJ is right here in the bottom right-hand corner. If I was to do ADJ, that is this huge thing right here. That's what we learned yesterday. So if it goes from the small one to something that's now 3 times as big, that's the last word we learned, that's a dilation. You can say this scale factor is times 3, but our word that we're trying to use this unit is dilation. Okay. So when it comes to the homework tonight, if that helps you, you can map them out in a different color like I did. So translation is if it moves over and then up, or say it goes down and then over. It doesn't matter how many it moves as long as it stays upright. A rotation will spin it. A dilation will make it either bigger or smaller. And then there is no reflection in this type of picture. If I was to flip it down, then my triangle would be upside down and it wouldn't keep that pattern going. Okay. In class today, though, your worksheet has some measurements for you to compare. And the directions just say tell whether the polygons are similar. If they are, go ahead and list the sequence of transformations that would do this. So in my picture, I'm looking first off, do I have the same shape? If it's congruent, then I can keep going. But if it's not, then we're going to look for a scale factor. So for example, 2.2 to 4 is not the same length. Okay. This is my medium size of the triangle compared to my shorter sides and my longer sides. So these two medium sides are not the same, but I can take 2.2 times 2 to get 4. Okay. I could also take the two shortest sides, 1.4 times 2 to get 2.8. Could I do that same thing with the longest sides? You betcha. 3 times 2 is 6. So the first type of transformation I would say is that it's a dilation, and my scale factor is times 2. Remember, we could also go the other way. If you'd like to stay smaller, I'm going to go ahead and draw my direction the other way, then my dilation would be times a half to make it smaller. In order for this to be true, though, every measurement on your paper has to be times by 2 for the side lengths. If they give you the degrees, those angles will stay the same, but every single side length has to match. If these were both times 2, and let's say this one was times by 3, then they're not similar. We'll notice though the picture doesn't look the same, right? It was times 2, but it also got flipped over this line. So our other transformation is a reflection. Okay. It could be a translation if it stayed upright and moved over. It could be a rotation if it turned on its side. But in my picture, I had the medium side to the medium side, the longest side to the longest side, and it just got flipped over, so it was a reflection. Make sure you list all the possible transformations that you can. If they're not the same rule though, if the scale factor gets flipped, or if one of the sides changes and the other ones don't, then there are a couple examples today on the notes in the homework that the solution is they're not similar. So don't write rules if these two shapes are not similar.